Hi everybody, here are our notes for our study guide that we made in class today. I just wanted to make sure you had access to them all. So our quiz tomorrow is on whether something is a function or not a function. So function is each x has its own unique y value. Not a function is if there is more than one x and there are some y's that go to two different y's, then it is not a function. If there are bunk bed points, remember those points that were up and down on a graph. If you had up and down points on a graph, it is not a function. Linear, a straight line on a graph. Nonlinear means an equation that has an exponent of 2 or absolute value signs. So again, when you go to graph, anything with a curve or a bend in it is nonlinear. So again, other examples of functions and not a functions. Function, each x value has its own unique y value. And when they're on a graph, there are no points above or below it. So here, all these x values have a unique y value to correspond to it. Our table form, 2, 3, 4, 5, 6, all go with a unique y. Same thing over here. We might have repeats of the 2's, but notice they have repeats of the 6's, so that is okay. Not a function. 2 of the same x's have different y values. So we have 2 of the same x's, the 2's, but they go to different y values. So 2 can't go at the 5 at the same time 2 goes to 6. So that is not a function. And then same thing here, if we have points above each other. So for instance, when x is 1, y is 1. When x is 1, y is 3. We can't have them on top of each other. We need to have, for every x, a unique y. Again, you have your evaluating your graphs. You need to show me whether something is linear or nonlinear. So linear, it makes a straight line when graph. There are no exponents greater than or there are no exponents greater than 1 when it comes to this. So we have our line. So these could be examples of y is equal to 2x or y is equal to x plus 6. Our exponent in the variable position here has to be 1 in order for that to work. Nonlinear, we have our exponent in the variable position up here has to be 2, 3, 4, 5, anything bigger than 1. That'll produce a curve. Absolute value also is nonlinear. So it's a graph that does not make a straight line. It has to have a curve or a bend. This person's linear and nonlinear. We had here straight line when graphed, no exponents, again, larger than 1. Constant rate of change. That's an excellent use of vocabulary. Nonlinear, no straight line, no constant rate of change. Has to have a bend or a curve when you graph it. So that takes us to rational or irrational. A rational number is any number that can be written in the form a over b, where a and b are integers and b doesn't equal 0. In other words, it's a fraction. Any fractions are rational. Natural numbers, whole numbers, and integers are also included in that rational grouping. I'd like to do it this way. I work backwards. If it doesn't follow the definition for irrational, then it must be rational. So in order for it to be irrational, a number can never make a fraction, it can never terminate, it can never repeat. We can't use bar notation for it, and it can't be written as the a over b fraction. Also in this one, I would add that a square root of a non-perfect square, the square root of a non-perfect square would fall in this particular category as well, because those will repeat and go on. Sorry, they don't repeat and they don't terminate. Then we have repeating decimals to fractions. So our first type here, we have x is equal to 0.2 repeating. So that's the one where we multiplied both sides by 10, releasing one of the 2's, subtract x weirdly, and we get divide, and we get 2/9. Remember that 2 with a bar over it, whenever you only have one number with a bar over it, it's going to be over 9. That was that example. This example here has all 3 cases. Great job here. When it's equal to one thing being repeated, two things being repeated, remember we multiply both sides by 100 and then subtract. And those ones will always give us over 99. And then the third type, we have x equal to whatever this is. And here we notice that the 3, let me zoom in on this. The 3 is not under the bar, but only the 8. So we multiply it by 100 to release this whole thing, and then by 10 to release this. These will cancel, and that will give us numbers to then divide for and then solve for. So that is that particular one. So the first type, again, has one thing being repeated, you multiply it by 10. Two things are being repeated, you multiply by 100. If there's 2 things but only one is being repeated, you have to do both, the 100 and then the 10 and then solve. And then the last piece here that we had, to go back, rational numbers. We have fractions, decimals that terminate, repeat, bar notation, whole numbers, integers, natural numbers. Pi over pi, remember, cancels to 1, that's okay. Example 4, 4.778, and so forth. Fractions, 4/7, that's all okay. Irrational are decimals that go on without repeating or terminating. Pi is irrational. Square root of a non-perfect square. Pi over 7, 6 over pi. These numbers here, as soon as you see pi in the question, it's automatically irrational, unless, of course, it can be simplified like over here. And then 3 plus pi as well is irrational. And then finally, the bottom, again, going from repeated decimal to fraction, we look to see how many times it's being repeated. If there's a whole number up front, it just gets along for the ride. So here, there's only one thing being repeated, so we multiply it by 10. That releases that 7. It causes those to cancel, and then we can solve. And over here, they're showing their workout by 10, 100, and 1,000, if it gets to this point. I won't give you any ones this big. So there's your review notes. Have a great day. Talk to you tomorrow.